Welcome to another video and episode on my Raspberry Pi 1 running Raspbian Linux, connected to network cable for VNC, serial cable for data transfer, and I will continue with that later. Two probes attached to receive and transmit for serial monitor, in this case the scope, oscilloscope, and also right on top of screen the Raspberry Pi camera and band cable towards this rather stacked breadboard with electronics, and in this case it's limited to this part of the circuit. Well, they're all separate circuits. This is one separate, this is a separate one, and this is a separate one. Actually one of the oldest that I have, that I'm using here. And this is an analog to digital converter, because the components are all analog ones, giving just values instead of ones and zeros. And via this MCP 3008 analog to digital converter, using the SPI serial peripheral interface protocol, it works towards the GPIO to the Raspberry Pi, and for this project programmed in Python. This already happened, it works nicely. So what's the purpose here? Well, to gather all serial data. Last time I finished by adding a data log to get everything nicely in it. Serially it goes to minicom terminal, where I cannot store data, and I'm also using the scientific language Octave to capture things, and there things don't go all according to plan. So what do you see here? Well, there's no LED, so all I can show you is putting a finger on here, on this LDR, light dependent resistor, or on this LDR. I could touch this NTC, but basically this is without blinking LEDs. This one and this one would work, but the wire is not connected, and apart from that it has nothing to do with SPI, so I'll leave it at that. And for all other stuff, let's go to the software, because that's way more interesting. So what do I have on software? Well, first of all, the virtual network computing environment with the PiScope running, no signal yet. Then for the same from the same terminal also a view from the Raspberry Pi camera, RaspberryCam for short, and this has a few seconds delay. So is it usable? Maybe. Then another view, then the oscilloscope, to which two wires to the oscilloscope are attached. Then my Python program and Octave, from which I capture data with something that I had in mind to do, if I'm going to make it to do it. Then also an attempt to get this done again. I'm not quite sure if you can see it, except for a lamp that I have to remove. So what is on this one? Well, the Pi scope as well. This is running VNC. So, well, another desktop from the VNC, and an attempt to see if when on the first desktop the Pi scope is running, if that is running here as well. Because I was already surprised that this tablet is starting the Pi scope again. And in order to see if anything happens, let's just run the software. And here's me putting it, so let's go. Yep, and there you can see everything. So now I see from this signal that I have to change that is better. And then the second I will change as well. And then time base. Yeah, let's keep it to this. So everything is working here, and to my surprise, to my pleasure, everything is working on the tablet as well. So let me show exactly that. I'm not quite sure if you can see it nicely, but all this is also visible on here. Is that nicely to see? Except for the camera, yeah, you can see it here. So that is a nice surprise. Then back here. So this is working. Now I can also, this is something that I had to align all, because indexing in Octave works with the same amount of data. And the only thing is now, how do I do that? I can, because of the data log, open another terminal, and let me do that right in here. Another tab, and then how is it called again, because that is important. I write it to data log. So data log, and that's it. Okay. And the typical thing is that here it appears nicely aligned, and here it sure does not. So that's a bit of a mystery. And yes, it is a slow computer. It is a RaspberryPi 1, so no quad core, no whatever. So that's something to keep in mind. But I would expect this to be written nicely. Am I doing that exactly the same way? That is then the pretty big question. SPI I'm not interested in. I'm interested in the real data, which is coming from here. And then I see that is not the case. And that is the point, of course. So I have to do some 6 dots. And it responds very slowly because it is processing. It is processing data on the screen. It is doing the pi scope. And let me also quit it on here, so I can run it in here as well. Running both minicom and Octave is going bad, although it doesn't say anything, because if you look at this, doesn't look like structured. Well, it is exactly the same data as you see in minicom. So let me start minicom again, and now you get anything but normal data, because some is sent minicom, some is sent in to Octave. So that is absolutely garbled. So when I quit this one, minicom will be structured again. Anyway, time to fix the data log to be nice, and then find a way to to grab things nicely per element in Octave. One thing is now that this is lined, and I made a very tiny mistake here, which I had to correct. So now this is, at least in the data log, nicely readable. And it goes on, and if I put my finger, oops, then it is wise to have actually this is green. So if I put my finger here, then LDR2 value should change, which it immediately does. And I take my finger off, and the value should go down, which it does not immediately. That is a bit strange. And this may be a better side. Anyway, back here. So that is working out. Now also with minicom, by the way, which is very nicely working. Although why resistor value is 0, I don't know, because it should not be 0 at all. But that's a different question. Now for indexing, because like I said, I want a value for LDR in the vector LDR, and LDR1 and LDR2, and they say use indexing. So that's the next step. Right, so the idea is to capture data from the circuit, write them to screen, write them into data log. Let me make here a tab and call it data log. That works. and this works as well. Except for when you're doing Octave next to it, that's a different story. So let me interrupt minicom, go to Octave. There I have added some lines. First, introducing a string called LDR1, because here I'm calling it LDR, but here I'm calling it LDR, and I am actually getting the serial thing. And now, yeah, there we go. Very slowly, too slowly actually. So I have to drag it slowly. Right. Okay. Serial write is LDR value, not LDR1. That is one mistake of mine. So remove the 1. Then a string compare with n characters. I want to compare the first 4 characters in this string, or in this vector. It doesn't complain, but if it is right, I don't know. Then if S1 and data2 are in the first 4 characters equal, then display equal. If not, display others, which means different. Does it work? So far it didn't work, but I probably compared with a different string. So that also means that I will have to change into 3, because LDR are only 3 characters. And now let's see whatever happens. Data2 should list. Why is data2 listing exactly the same? No, it's not. Here data2 is listing LDR, and here you see equal. That is very good. This is very good, so it does work. And here it is exactly the same. So this comparison does work. So now if this is equal, how many characters further is the value? That is actually 1 plus 5 is 6, 7, 13, 14 is 15 characters further. So I have to read that 15 further, and that is a challenge. So I will have to say that if this is being sent, I better read everything which comes after. So this is better. So 3 plus 1, 6, 7, 13, 14 is 17 characters equal. Now test if that is going to work, and then maybe I can grab the value, just maybe. Do I see gelijk in on screen? I don't see, oh wait. Here I see LDR value, but it is not the same. So why is it not the same? Is it not 17? That could be. No, because simply said it's only 16 characters. So I have to be with 16 then. It's only 16 characters long. Oops. Am I seeing LDR somewhere? And I don't yet. Here is LDR2. LDR2, but I do not see LDR value. So it won't ever be equal. And this is actually kind of indexing. So and what if I do it again like this and then put this back to 3? Will this work again? It should be. Alright, testing. Do I see data 2 with LDR? No. Although here I do see LDR, but it's not the first one, because this is starting with a space. So it's not the same. The first character has to be LDR. So yes, that is a challenge. And another thing is, usually this way of indexing is used, as far as I've understood, with non-changing matrices. And this program is running continuously, so the content changes completely all the time. So that is kind of hard. Alright, changing back, and if you well, changing back to 3 as I showed, and if you see then all this data coming by and there's only one that is equal, then you see how hard it is in this way to compare the data. It's nowhere equal except for the highlighted one, and data continues to flow. So is the indexing a good way to do it? It's a slow one. It's a very slow one, because after this one, and why this doesn't work, I'm not quite sure. Probably because of the fact that I have to extend then the data into even more characters and then be able to catch the data and then store the data actually in here in LDR, because that is what it is about, storing the data, and that is not happening right now. And I probably would have to use data 2 plus something. but that's for a different time. In the meantime, I also, yeah, this is stopped, so I can start minicom again. It's very nice data. In the meantime, the serial port is running nicely, and if I give some enters, you can see data going return on the other probe. And I have next to breadboard also the Android tablet, and as you can see, it is barely watchable with the camera. With the bare eye it is very good watchable, and if I look right here, the data is the same, exactly the same. Can I now also do the same thing from the Mac? Because if I'm correct, and it has 3 VNCs, let me try that one. Because I already was surprised that it started a second instance of the PiScope, but I'd like to see if this one is correct as well, if the third one will work. And this is, to my surprise, already running, but it is number 3, which is the same as on my Android. So what I have to do now is quit this one and select from this one number 2. And this is what you usually do not see. And this is an empty screen. So now I'm no longer watching the same thing as on the Android device. Now I am waiting for yeah, now I have a window. That is nice. Oh, and the second one, because I was rather impatient, but it doesn't really matter. So I have to go to the PiScope directory and start PiScope. Will it work on here as well? Then I have 3 PiScopes. And with 3 PiScopes it will have even more latency. And yes, I have a third PiScope running. And here you see that only TX transmit is running. So what is receive doing? I am going now to the first desktop, minicom, and I start pressing enter. And what will happen now? This, I release enter, and it returns to its formal image. Press enter again via the terminal and you see whatever happens. So that is perfectly shown on PiScope. As well as on the oscilloscope, by the way. So that is a very nice view. So with that new experience with Octave and with both VNCs, both I mean then apart from the standard computer, Android and the Mac you just saw, of which I managed to get actually this VNC also on the Mac at first. I was surprised that even worked. So although I did get something nicely out of Octave, it's not working as I expect. That needs some more attention. Anyway, if you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion, please. Much appreciated. Also, you can follow me via Instagram and Twitter. And if you like this series of videos, please subscribe to my channel and leave and make a donation. Very much appreciated as well. You can donate via PayPal or Wired, and you can also choose to become a patron, and you may have your name mentioned depending on the pledge you make. And your name will be mentioned in various ways depending on the pledge. This is going to be continued. For now, have a nice day and bye bye.